Python object-oriented programming, or in short, OOPS. Object-oriented programming is a way of programming big things so that the resultant is the most optimized code. What I mean is that this is a way a program should be written. By program, I mean the big application. You may think of something like the whole Windows app, the whole Windows OS. These, when the project grew and when there are a lot of features and a lot of things inside a program, then it's quite hard to maintain the usability inside the code. To have the most optimized way to debug the code or to write a new part inside a code or to update a code, this is a structure. There are some theories which you should follow inside your code to have it to be of most optimized way of editing and using it. So there are some theories in object-oriented programming which tells us how you should code and what are the things which are needed inside your code structures to make it the most efficient. So the object-oriented programming first, as the name suggests, it wants objects to be created, and to make an object we need a classes. So everything will fall inside the classes only. That's why we studied about the object and classes. Now let's talk about the other pillars of object-oriented programming one by one. Inheritance in object-oriented programming. Inheritance allows us to define a class that inherits all the methods and properties from another class. Like there is a parent class which has all these parameters and all these methods which are already made inside the parent class. Now we want a child class to inherit all these uh, details, all these parameters and method from the parent class. And we should be able to do that inside of Python. And this property of doing that is called inheritance. So let's see how we can make two classes and inherit from the parent class, inherit something into a child class. Let's see with some examples. So here in this picture, as you can see, we have two classes made. But while defining the person class on the top, we don't have any parentheses. While in the second class, student, we have in the parentheses the person, the person class. This is how we define that the student is derived from a person class. As every student is a person, but every person is not student. So person is a parent class and student is a derived class. Let's write this code and understand while writing what are each of these components and how is this code exactly parent and child classes, and how is the inheritance property actually working. Let's create our person class, and within init we can give self name age, self dot name we can give it as name, and then the self dot age we can give it as age. Now define the greeting. Once again we give the self as a first parameter and we print welcome, then the name of that person. We have defined this person class. We can test it using person, and we can give name as person name and the age as 22. Now let's access this greeting method from me object. We can do that using me dot greeting, and don't forget to add the parentheses as it is a function. Let's run this, and we got welcome person name, and we are printing, although we are printing inside our greeting function. So let's remove this printing part which is redundant here. Let's run our code. We got welcome person name. So this is how a normal method works. Now let's try to create a children class for this person parent class. As we studied, we can have a student, and inside, while defining the student class, we give person and specifying that person is a parent. So inherit all the method and properties from this person. And we can say pass. Pass means nothing, just pass this line. And we need to have one line to create a class. So we are doing nothing. We don't even have a constructor class or init class inside the student here. We just pass these properties. Let's replace this me object to student. Sorry, let's leave it as it is. And now this me is same, and but we can replace this person to student. Although we have not defined any in it, that's why we don't have any place to give any parameters inside the student class. But we will go ahead and let's see what our result will be. So the results are exactly same. We are printing welcome person name again. This is because although we have uh, defined all the details inside the student class, but the student class was inherited from person, and all these details were actually also being executed inside this person class here. So this is how we use an inheritance. Let's know more about the inheritance in the slides. So right now what we studied was just using another class and specifying a parent for that particular class. And by default, Python inherits all the details from its parent's class. Now, what if we want to add some more features or add or use some of the details from its parent class? How we can do that? Let's see that inside a code. So if we use a constructor class here, which is init, and again have a self, and then if we want to add the last name of a person, and we can have it here, and then in the last name we can give last name. Sorry. So self dot last name is now equals to last name parameter inside this function. Let's try to give this last name after all the details which we gave. Save this. As you can see, there is student with red underlined. This is because, let's run this and we'll get the error. It says got an unexpected argument name. what is happening is that when we define the init inside our student class, now we have two constructor class, one of person and one of student. And when we define the student constructor class runs while the person constructor class did not get a chance to run. That's why we got the name, we got an error that name is not a parameter because the parent class constructor never got a chance to run. Let's see further in slide how we can resolve this issue. So let's open our text editor again. In Python, first thing which we need to know is this super keyword. This super is a function which actually calls the parent class here. Then we want to call the init function or the constructor for a parent class. So we'll use the init method here. Now, as the person class takes two parameters, which are name and age. So we must give these parameter here. Now we are inside the init function of a student class. We must have the name and the age in the parameters of student also so that we can pass it to the person class. Let's add them here, name, age. Now, whilst defining a student, you will have this name and the age parameter, and this name and the age parameter will then be passed to the super function which will call our parent class. So this is the place where our parent class will be called, and its init function will be called using these arguments which it wants. And then we saved our self.lastName in lastName variable with the self. Now let's try to run our code again with the student only and passing all these variables. Remember, we are using the greeting method which is defined in person only. Let's save this, run our code. We got welcome person name. So after we initialized our parent class constructor, all of the features we can use, and we can even add more features or more properties inside our student like this. So this is the true inheritance. We can inherit any property from our parents, and we can even add more properties from ourselves. So this is inheritance in Python. Let's see more uh, in the next slide. Encapsulation. Encapsulation describes the idea of wrapping data and the method that works on data within one unit. This put restriction on accessing variables and methods directly and can prevent the accidental modification of data. What this means is that, like earlier in inheritance, we were able to use any property and any method of the parent class. But what if we want to hide some detail inside the parent class? What if some parameters we don't want our object to access from the outside? Now the encapsulation principle or the encapsulation theory comes into play. We need to define the variables in three ways. We must be able to define the variable in these three ways. One is a public member, second is a protected members, the third is private members. These public, protected, and private members can have properties and methods. So as the name suggests, public members will have all the properties and methods which are publicly available to the object. Protected members are the members which are protected from using formed from the object, while the private members are the members which are prohibited and which you cannot use even in the derived class or from outside of the object. Let's know more about encapsulation in the next slide. So here is the code for explaining encapsulation. Let's use our text editor and see what do we mean by encapsulation. So first thing to know is that to make a member or a property or a method a protected or a public, and how can we make it private? So by default, all these members which are properties and methods, by default they all are public. So as we saw, we can access this greeting method from the object from outside because this is a public. This comes into a public member. Next is if we want to protect some member which we don't want them to access from outside, is that we use a single underscore while defining their name. So now this member or this property age is now protected, although you can access it from the outside, but it is not advised to use underscore to access the members from outside. So we can say that this property uh, is being protected. Let's try print it. We can say me. Usually how we access the property is directly assigning their name, but as there's an underscore in a name, that's why we will say it is being protected. But although it is only protected, it's not private, that's why we will be able to print it. So we got the number 22. But as you can see, if someone will see that there's an underscore, uh, they can directly see in the code that someone is using a protected member, and which is not advised. So this will help them to debug some error. Let's get back to our slides to know more. Now we have a private member. How to define a private member, and how can we see that the private members are not being accessed from outside? Let's see that in the code. Similarly, we right now we make this age variable as protected. Now let's try to make it private by using one more underscore. So all the methods or the properties which you want to be private, that you don't want people to access from an object, you can use this double underscore. Now let's try to access our double underscore, then this age parameter. Let's see what will happen. It gives us attribute error. The student object has no attribute double underscore age. Although we know we have this double underscore age parameter. This is how we can actually protect uh, or actually we can create a private uh, private methods or properties. Similarly, we can do that for greeting. We add a double underscore. Now we cannot access this greeting method from outside. Let's try this. We got an error because this double underscore made this a private method and we cannot access the private method from outside like this. Let's get back to our slide to see more. Next, we have polymorphism theory. What is polymorphism? The word polymorphism means having many forms. In in programming, polymorphism means same function name but different result. For example, um, let's say when you want to add some numbers, then let's say you want to make a function which can add n numbers and this number is not defined. You can have 3 numbers or 4 numbers or 5 numbers. How can you do that? The number of inputs are not defined. Similarly, if you want to get the length of a string or a list or a dictionary, we use a length function. Although to calculate the length of a string and a list and a dictionary are a different task, but the name of the function remains same. This is the base concept of polymorphism. The name is the same, but the functionality differs when we use it on different objects. Let's try to see this in code and we will understand more there. Let's open our text editor. Let's clean this. Let's have a student class where we have defined its name and let's give this as self.name is in the name. Then let's define a greeting. Let's call it greet. Then within the self, let's print hello, then the name of that student. Let's create another class which can be a teacher. Let's define init with the same self and name. Self.name is equals to name again, and let's define our greeting function for teacher class. We can have the same name. Now the greeting for teachers will be different and the teaching and the greeting for student will be different. For teacher, it may be good morning or good evening. Good morning, then the name of the teacher. Now let's create 2 objects, one of student class and one of teacher class. Let's say me is a student of student class with the name, my name, and the sir is an object of teacher class with the name sir. Now let's print their greeting with the help of the object me.greet, and for sir the same function greet. Let's try to run this code and we see the hello, my name, and then the good morning, sir is being printed as this is the greeting for the student and the good morning, sir is the greeting for the teacher. So the name of the function is same while the functionalities are different for both of them. The best way to perform this code will be to keep both of them inside a list and use a for loop. Then, and then we will call this greet function only once. So let's say for people in list me and sir, for every people call greet function. Let's save this and run our code. And we again say greeting for both of them are being printed here. So right now, this is the best case to explain polymorphism. We had the same function dot greet method, and on this particular method, we had two different outputs, and those output depended upon the different type of object it was operating on. So this is how you create polymorphism or the polymorphic functions inside Python. Let's get back to our slide. Now let's create a polymorphic function with some inheritance. This is one of the most famous example you will see within a polymorphism, and it is asked in many frequent examinations. Let's see this inside of a code. So the idea is that for square and for rectangle to calculate an area, the formulas are different. For square, you just need one side. For rectangle, you need both sides. But in code, we want to call only one function. We want to make only one function, the area, to calculate the area of square and to calculate the area of rectangle. This is the best use case for polymorphism. So let's create that. So let's create our square class and let's create our init, and while defining a square, we just need a side of it, and the side is sufficient to calculate the area of a square. We can save this parameter side in self.side equals to side. Next, create a method to calculate an area. We'll give it the self parameter, then return self.side into self.side. This will give us the area of a square. Let's create a class for rectangle. And as every rectangle, uh, as rectangle can also be a square. So let's have the square as a base class for this rectangle. In the init, let's define the self, the length, and the breadth for this rectangle. And then let's call then initialize our square class using super. And to initialize its constructor, we use init. Then we can say the side is actually just the length. Then we can save the breadth as self.b. Now we can overwrite this area method in the rectangle, although this area is being defined inside the square only, and every rectangle object will also have this method accessible. But we will override this area method for rectangle classes. Let's create our area rectangle area method, and inside it, let's return self.length into self.breadth. Self.length self.length was defined inside the square. So this length is actually the side. So self.side into self.breadth, as this length was going inside the slide parameter, and then the slide parameter was being saved as self.side. And the self.b is actually the breadth parameter, the value of the breadth of rectangle. Let's create our two objects, one square and one rectangle, and try to print their areas. While creating a square, we just need to give one value, which is its side. While creating a rectangle, we must give both values, length and a breadth. Now, again, let's print their areas. Now, let's save this file and run it. We got 25 and 50, as 25 will be the area of square of side 5, and the area of rectangle of side 5 and 10 will be 50. So this is one of the best use case of polymorphism using inheritance, and we actually shorten our code. We did not need to define the another parameter here, and and you can imagine when your project grew, and there will be many more things which you don't actually want to define again and again. You can use this polymorphism and the inheritance like this. And in this short example, you can see it actually saves some lines of code. Let's save it and get back to our slide. So this was polymorphism in object-oriented programming.